4, and we're looking at the Wednesday column. We're starting off with some addition and subtraction of decimals. Let's start with our addition. I like to put a 0 here so that every place value has a partner. It is a good habit to get into. We have 1 plus 3 is 1. 5 plus 4 is 9. 4 plus 6 is 10. Here's my theory, my 1 plus 2 plus 5 is 8. And 6 plus nothing is 6. Boys and girls, remember to line up your decimal so that you can bring it straight down into the answer. And there is our answer. Let's go ahead to the subtraction. If I have 1, I can't lose 7. So I have to come to the 5 and borrow. And now I'm going to regroup. This 1 is going to become an 11. I have 11 minus 7, which is going to be 4. Now, remember, we made this a 4. Well, 4 minus 5, I cannot do. So I'm going to borrow from this 4 and make it a 3. And this is going to be a 14. 14 minus 5 is 9. 3 minus 3 is 0. And 2 minus 1 is 1. I'm lining up my decimals. I'm bringing them, and I have my answer to that question. Okay, boys and girls, this next one is asking us to think about counting up instead of simply subtracting our decimals. So here, boys and girls, we're thinking about that Mr. Smarty Pants question from last week. And with the Mr. Smarty Pants question from last week, what we actually did is we started at this number, which is 48 and 55 hundredths, and we counted up to get to, in this case, 74 and 52 hundredths. Okay, so let's take a look at how we could do that. Well, first of all, we can make a small leap to come to 49. And when I take that small leap to get to 49, what I'm doing is I'm going to go up. I'm going to write it here for us, nice and small, 45 hundredths. When I go up 45 hundredths, I'm getting to 49. I'm going to go ahead and write that out. I had 48 and 55 hundredths. I added 45 hundredths, and I got to 49, right? That was my first step on the number line. My next step on the number line could be different things, but for me, what I'm wanting to do is go ahead and make a really big leap to get to 74 holes. Since I'm at 49 holes right now, let's make a big leap. And let's actually go all the way to 74 holes. So this big leap here is where I'm going to go from 49 to 75, which if you're unsure of what that is, you could go ahead and write it out. But I know that that equates to a big leap of 25 holes. So once again, let's write out this equation. We're going from 49, we're adding 25 holes, and that gets us to 74, very close to our answer. Now we need to make just one small leap. That's going to get us to our answer, which we're trying to get to. And here, what we have gone up is those 52 hundredths. I'm going to write that out down below because once again, this helps me to show you what my thinking is, but it is very, very small. So I'm at 75, but I'm going to add that decimal value that I still need to jump, and that gets me to 74 and 52 hundredths. Okay. Now, boys and girls, what I'm going to do is I'm going to think about these jumps I made. This jump was 4,500 hundredths. This jump was 25 holes. This jump is 52 hundredths. My last step that I need to do to figure out exactly what that distance was from this to this, my very last step is to add those 4,500 hundredths plus 25 holes plus 52 hundredths. And that, in all, is what gives me my answer. And my answer here is, let's see, 25, and combine those hundredths. 5 plus 2 is 7. Combine those tenths. 5 plus 4 is 9. That's where I get to my answer, 25 and 97 hundredths. So again, this might not be the most efficient way to do it for you, But for Mr. Smarty Pants and for some, this is what makes no sense. And it helps our brain, it's good for our brain just to examine a different strategy. Let's move on to Alexander the Late. Well, he was supposed to collect this many grams of Roman coins for the treasury, but he didn't arrive with that. He only arrived with this many grams of coins. So we want to find out exactly how short he was. So the strategy, I need to use a subtraction to find the missing part. 9 minus 4 is 5. 7 minus 7 is 0. 4 minus 9 I can't do, so I'm going to borrow. And I'm going to regroup. 14 minus 9 is 5. Now, 0 minus 1 I cannot do, so I'm going to borrow from this 4. I'm going to give 10 to the 0, so that becomes 10. 10 minus 9, or excuse me, 10 minus 1 is 9. And then 4 minus 2 is 2. So my answer to this problem is 29 and 505 thousandths. But we got to remember what that was. It was actually a measure of grams, right? So we were measuring the weight of the coins with a metric unit, grams. Okay, let's go to our next one. Boys and girls, we are thinking about neighbor numbers. When I think about neighboring numbers always have a relationship of 10, whether they're 10 times bigger if we're going this way, or they're 10 times smaller if we're going this way in our place value system, right? Well, this too is traveling this way when we're comparing the cups to the tank, and it's traveling this way when we're comparing the tank to the cup. So it really depends on how your neighbor number questions are asked, whether it's getting 10 times smaller or 10 times bigger, okay? So our first question asks us to think, how many times as much as the cup does the tank hold, right? How many times as much as the cup does the tank hold? That's what my very first question is. So what I need to remember is that I'm starting here at the cup and I'm trying to figure out how many times bigger, basically, the tank is. Well, if I were to have just moved this 2 from the hundredths to the tenths place, that would have been 10 times bigger. But I kept it moving, right? If I would have moved it all the way here to the ones place, that would have been another 0, 100 times bigger. But I actually moved it all the way over here to the tens place, so that is 1,000 times bigger. That's what I need to think about in this problem. This 2 moved here, so it got 10 times bigger. Again, 100 times bigger. Again, that's 1,000 times bigger. Okay? Now, the opposite relationship is here when I compare the tank to the cup. The tank is how much the size of the cup? 1,000. The cup is what size of the tank? Well, it is 1 over 1,000. So it still has a relationship of 1,000, but we must remember that it's actually 1,000 times smaller, which is why I'm going to reflect it as that fraction. Our last question for today, we have stayed focused through questions. Some of them definitely take some deep thinking. Here, we know the base of King Tutankhamun's pyramid had an area of 51,750 meters squared. The pyramid had a length of, so I've labeled the length, 230 meters. We want to find out what the width of it is. Boys and girls, remember, area is the length times the width. Well, I know my length. My length is 230. What I do not know is the width. I have to find the width. What I need to do in this problem to figure this out is I need to divide. Boys and girls, let me get a little piece of paper and let's go ahead and do division on this because I'm going to need a little bit of space to write. What I'm dividing, my dividend, is that overall area, 51,750. I'm going to go ahead and write that down for now. Now, I am going to break that up by the length, which was 230. Now, wait a minute. I see a 0 here and a 0 here. Can I take off an equal number of zeros if I see a 0 on the end in the dividend and a 0 on the end in the divisor? Absolutely. We have seen in our lessons that we can lose this 0 and this 0 And as long as I treat it fairly and I lose the same number of zeros, that's a great strategy to make it a little bit easier because I'm making both of them 10 times smaller. I'm treating them fairly, and division is all about fairness. So, boys and girls, now what I'm really thinking about is 23 groups in 5,175. Okay? So, first of all, our 23 times tables were not ones that we memorized. So, we can come to the side and we can make just our little brainstorm. 23 times 2 is 46. So, I also know that 23 times 20 would be 460. Now I have a good idea here. Because if I do 23 times 20, I'm going to get 460. Well, that's still far away from this. But couldn't I add another zero and make this 200? 23 times 200 is 4,600. And indeed, I'm going to use that fact. 23 times 200 is 4600. And that is a good place to start because I'm taking a good portion of this, but I'm not taking the whole thing, right? Can't go over it, but I want to get as close as possible. 5 minus 0 is 5. 7 minus 0 is 7. 1 minus 6, I can't do that and stay in the positives. So I'm going to borrow. I'm going to regroup. Now I have 11. 11 minus 6 is 5. And 4 minus 0, of course, or 4 minus 4 is 0. So now I have 517 left. Well, if I look back at my facts, this would be a good one to use. 23 times 20 was 260. So I'm going to use that. I'm going to use that 460 that I get from 20 groups of 23. And that is a great place to begin. When I look at that, I have a difference of 115. Now, there is a fact that perfectly uses up all of that 115. If you're unsure of what it is, because certainly these 46, not very close, you could guess and check. This is what good mathematicians do because we didn't memorize our 23 times tables. Let's try 23 times 5 because that might work, or I might find out that I need to be a little bit bigger or a little bit smaller. 5 times 5 or 5 times 3 is 15. 5 times 2 plus 1 is 11. And take a look, boys and girls, that is the end of this problem, but certainly also the end. That was 5 groups. The end of this daily practice. As soon as I combine these, my 200, my 20, and my 5, 225 is my answer. Remember, boys and girls, that is telling me what the width is. So I'm going to take this idea, 225, and I'm going to say the width equals 225. And what was the measure? It was in meters. Great job, boys and girls. These questions definitely took some grit, but certainly we did some good review in this Wednesday